Good afternoon, good morning, good evening for those that are joining live versus those that might be watching this recording at a later point in time. We'll give folks to, I guess, gather on in terms of the sessions jumping from one to the next. So we'll give them a few minutes, or I should say a few seconds before we get started. Quick introductions for those who may have missed my earlier keynote. I am Navin Sharma. I'm the VP of Product at Stardog, based out of Arlington, Virginia, here in the US. And I'm excited to bring another topic, a little more deep dive from what I covered during my keynote, which is the idea of knowledge graphs, semantic layers, and the combination that delivers a notion of data democratization that's been talked about quite a bit, in fact, in the industry. So with that, I'll jump right into it. So I talked about this in my keynote. This kind of summarizes for me the challenge as data innovators that we have to overcome within our own enterprise organizations, which is dealing with this growing level of data volume and distribution, which is really making it harder for organizations to exploit their data assets efficiently and effectively. Now, one of the things Gartner, through their recent research report, published, and frankly, we agree, was this notion of companies thinking about adopting a semantic approach to all of their enterprise data. Otherwise, they will continue to face endless battles with data silos. So it's important to set the stage in terms of what a semantic approach is. If you think about a semantic layer, right? A semantic layer is essentially a business representation of all of your organization's most critical data. And a business representation that kind of helps end users access this data autonomously using common business terms. And what does that mean? These could be complex data maps that are translated into familiar terms, such as products, customer, revenue. Really, the goal there is to create this sort of unified, consolidated view of data across the organization. Right? So we think about it. We think about it as concepts. We can think about them as things relative to strings in how we structure and store the data. These could be references, objects, and or even more commonly used terms in terms of ontologies. But the idea here is that the semantic layer is built to enable the larger community of users that don't necessarily sit in enterprise IT, right? They're not data engineers or data scientists, or have the skill set necessarily to work with data as some of the more specialized skill sets do. And so when we think about the semantic layer, really what we're saying is it's this notion of taking the metadata, that is the description of the data itself at the source, and enriching that semantically to deliver some new insight back to the business. Now, let's kind of play this out with a very concrete example that I believe will resonate with a lot of folks, just from an easy to follow example purposes. One of my co-workers or peers just went through a session on this particular data set. This is a representation of the British royal family. You can kind of see that hierarchy of relationships, all the way from King Charles III on the top to Prince William and their kids down with Prince George of Wales. And so that representation of that hierarchy of relationships is represented on the right-hand side with two tables that we may store, excuse me, in a relational data context, right? So a table that has the person's ID, their member's name, and their gender, and then a table that kind of creates this relationship between the parent and the child, right? So we know that parent 0 has child 1, and parent 0 also has child 3, and parent 0 also happens to have child 5, parent 1 has child 8, so you get the idea. And we look at this in the context of our relational world, right? In terms of how data is structured and stored. we have this, what we call metadata, which is the data about the data. And it's a person ID, a name, a gender, a parent ID, and a child ID. And then we have the actual representation of that information as the instance of that data. So we can see Harry, Duke of Sussex is the name, gender is male, his parent ID is 8, and his child ID is 29. And we kind of look at it from a conceptual data model. Really what we're saying is we're representing this information where members are parents of other members within this hierarchy of relationships. Now, that's a fairly easy model to follow. However, in the real world, we know that the relationships that we might be interested in are a little more complex than just the pure parent-child relationship. We want to understand members' relationship from a grandparent perspective. We may want to understand member relationship from a sibling perspective. We may want to understand the relationship from a cousin perspective. And so those relationships mean that we have several options here, right? One, we reshape the data, which is to essentially say we basically rejiggered the data model, add more tables, add more joins, and republish that out for someone to be able to consume this information with these relationships defined. Or we create complex data pipelines with even complex transformations that we write and encode and script in order to surface these relationships back to the end consumer and the end user. But we don't really want to do either one of those options. So is there an option C? So let's look at that, right? What we really talk about semantic enrichment and the idea of a semantic layer is, number one, we're not interested in reshaping the data model. And we want to avoid, like a plague, as much as possible, the idea of creating these complex data transformations. Now, representing the model on the left is really what we want. And so what a semantic layer does, it allows you to represent the actual data model as described on the left-hand side of the screen. So the description that you're seeing on the left is the actual representation of the data model that gets represented for the user as the actual schema itself. And then last but not least is you want to be able to infer these relationships based on certain domain rules. So what are domain rules and what do we mean by inferring relationships? Well, let's take a look. What really that means is we want to annotate that data model with these specific rules. And those rules are as follows. A grandparent, so if we can describe it in context of if then else statements, a grandparent is a parent of a parent. A male sibling of a parent is the uncle of the child. If a person has a child, then the person is also the parent. So we're annotating the actual data model with these domain-specific rules, which then allow us to really infer the relationships rather than having them physically manifested or explicitly defined in the data model. We can infer these relationships and present that back to the actual user. So what does that translate to? Now I can basically, using the same data set. Now, one of the things here is the data set I'm looking at has not changed. It's still these two tables inside of where this is sourced. And I am now enabling the consumer, however, to be able to ask questions of the data in terms of new insights that is not necessarily represented or manifested in the physical representation or structure of that data itself, but as part of the semantic data model annotated with those domain-specific rules. So I can begin to ask questions like, who is Harry's grandmother? And get answers back like Queen Elizabeth II. Or I can ask questions around, all of Harry's relationships. Cousins, siblings, grandmother, children, parent. Well, that list is too long here, but you get the idea, right? I can ask the question and get the answers that I'm looking for in context of all of those relationships without having to physically rejigger the underlying source data model by creating the semantic model that's abstracted away from where the data is stored and annotated with those domain-specific rules, which are basically a bunch of if then else statements. So what does this all mean? It's all well and good in the context of the royal family, but in the real world, this is all about enabling use cases across a whole host of industries, where the needs of having data connected across that data supply chain, across those silos, is just that much more important. And it's reflected in this particular slide in terms of 3 different industries, but not necessarily limited to these industries, right? So when we look at healthcare and life sciences, and we're talking about use cases around drug discovery or preclinical R&D or molecule to market, right? How do we enable researchers and scientists to garner all information that's related to studies, research, drugs, compounds, suppliers, materials, raw ingredients, reactions, clinical studies? How do we bring all of that information in ways that enable the researcher and the scientist to ask the questions, much like I demonstrated earlier with the royal family example, and get the answers they seek so that they can accelerate that drug discovery process? Manufacturing, same notion of understanding and creating the entire supply chain digital twin, and being able to look at a bill of materials associated with, for those that have worked in the industry and manufacturing, this complex hierarchy, a BOM representation of all the products and goods, cross-reference with all the suppliers, and those complex hierarchies and the relationships can really get very hard for anyone to follow, let alone a specialized skill set in a data engineer. So how do you represent all this information across the digital twin, across the supply chain, so that a factory floor analyst can understand the information in ways that they can make decisions or react, right? So some part has gone bad in a particular vehicle. What parts, what other issues have been associated with that particular vehicle or with that particular material? Who are the suppliers of that material? You get the idea, right? So the notion of understanding this information so that a factory floor analyst can answer and respond. Financial services, same notion, right? So now we're talking about customer 360 types of use cases, whether it's in the context of know your customer from a compliance perspective, or tracking the money, flow of money from a financial crimes perspective, or even just from an operational risk perspective, right? If a data center goes down and there's dependency on multiple applications within that data center, and that data center has infrastructure support, who are the experts, who are the people that should be notified? What are the implications in terms of the certain applications that go down, and what infrastructure supports those underlying applications? Who are the vendors to contact, right? All of that operational risk type of information, IT asset management type, can really make a difference for the individuals that are, again, not necessarily central IT, but individuals responsible for running the operations of the business, right? So this could be the compliance team or operations team that don't necessarily come with the deep technology skills necessary in order for them to make quick decisions and have a broader understanding of these relationships across the data supply chain. So let's take a look at a few examples, make this a little more concrete for you guys. Let's take this notion of supply chain resiliency, right? So here's a notion of a quality note that's associated with a fender burn through a vehicle that was reported, a particular VIN number that triggered what's called a stop shipment in a factory, right? So there's been a notification about a fender burn where there's a potential of a recall, but before even that gets triggered, the idea is to make sure that they can stop shipping a particular part or the vehicle that uses those parts. But then what's important to quickly analyze when we look at it from a supply chain perspective is, are there other related quality notes for this vehicle? This is in the context of a factory floor analyst, right? The individuals responsible for the supply chain and operations. Was there a resolution for the quality note that was logged? What materials make up the impacted components? Are those impacted materials being shipped by one supplier? And if that one supplier just happens to be in a geography or a location where there's some political tension, what does that mean in terms of finding an alternative supplier, and how does that jeopardize the production, ultimately the production and rollout of the particular vehicles in question? What other orders are potentially impacted that are already in flight, that may need to be essentially paused, right? So looking at it just purely from a supply chain perspective, you have these questions as the factory floor analyst, and then your immediate goal is to be able to ask those questions and get answers to those questions. And the way you kind of do that in the context of a knowledge graph built or powering a semantic layer, now let's take a look at that, looks something like this, right? So I'm going to open this up. In fact, I'm going to open up a view of how this could be reflected. And what you're seeing is like a Google-like search engine looking screen on a browser. That's one of our applications, Stardog. It's an application called Explorer. But the idea here is that what we're doing is representing the underlying data in ways that has sort of meaning associated with it. So meaning that is relevant to the user and the use case that is consuming this information. So assembly jobs, base machine codes, controllers, dealers, departments, engines, engine measurement, factory, location, market classification, market segment, materials, model year, product family, you get the idea. So if I were to take an existing query that I had created and saved, so I want to understand quality notes by a particular vehicle VIN number. You saw on the slide I had earlier, I had the vehicle VIN number going back here, WHCL00, you get the idea. So if I go back here, I can see that particular vehicle number. I can see the specific query that I used to create this based on that underlying business meaning. So I'm looking at quality notes for particular vehicles, and this particular vehicle happens to have this VIN number that I'm feeding in as my query. And I can see that this has a quality note around what's called their trunk door seal, which seems to be damaged. And if I want to explore beyond that view, I get to see that there's a particular material, a black rubber seal that has an issue associated with it. It came out of the DC manufacturing plant. It has a non-conformance attribute attached to it where the trunk door is sealed, is damaged. And I may want to look at, from a material perspective, more information about, where is the source of this information, or from a trunk door perspective, where have other non-conformance reports, been associated or originated from. And we know that it originated from this particular identifier, which has 7 other non-conformance reports, where things like burn through, out of joint. There's a chemical removal washing process that was mocked for demo. So we get to see this notion of how things relate across this entire supply chain, from where it was first reported, to the material, to the supplier, to other reports associated with that same material from other locations. So I can quickly make decisions about whether or not I want to better understand the stop shipment and make that decision. And that, obviously that is one example here, just to get the point across. I can look at it from the context of use case of drug repurposing. So this is in the case of life sciences. I want to understand drug interaction studies associated with oxytocin related to autism. So I can understand certain genetic conditions that might be suitable for treatment with autism, or I might understand, other compounds that have been tested in similar conditions with similar treatments. I want to understand, which manufacturer supplies those raw ingredients, and maybe understand what other studies are relevant. So if I look at this same type of example here, like I did for manufacturing, I kind of look at it from a life sciences farmer perspective. And you can again see I've created this notion of business objects that are relevant to my consumer and use case. And what I'm doing is really querying the source of the data, which can come from your data lake. It can come from your data warehouse. It can come from PDF documents that, we have extracted relevant entities from. It really doesn't matter. Some of that data is materialized. Some of that data is left at the source and federated over every time I issue a query. So let's look at that, right? So let's look at all the studies associated with autism that have oxytocin. I can quickly get to that answer There's 5 other studies associated with that. There's a particular one around autism, oxytocin, and I can kind of pull that out. I see that there's 5 different sites that have that reference this particular one. University of Miami, Northeast Florida State Hospital. I can kind of look at which university or health facility has sponsored this study. So I can start to look at different relationships across those. And I can even break this out and say, what other studies are associated with autism that I need to understand? What other drug interactions, for example, that are relevant for me to understand and look at? What other studies I might be interested in looking at from a publication standpoint, the research that I'm trying to conduct. What are the sources of some of this information? So there's tons more that I can start to review across this entire supply chain of data that, again, can be sourced from a multitude of silos inside the enterprise. And the same goes, by the way, when we think about it from a financial services or financial crimes perspective, board members of companies where they are investigating people that also work at a particular company, right? So what other companies are they associated with from a board perspective? Is there an affiliation to certain individuals that are under investigation for crimes? What is their financial investment or stake in those companies? Where are those companies located? What transactions have been associated with those individuals? Are there subsidiaries of companies and their affiliations? So I can use, the same idea, same notion, apply it in the context of financial services. So let's take a look at that real quick. In this case, I've already created a query called an investor-employee relationship. And I'm looking at, I just kind of randomly use an example here. There's no commit, these are all dummy data. I'm not saying there's any fraud associated with any of these companies. So this is just a synthetic data with some examples, right? So I can quickly see that there are 2 people in Stoica and Ben Horowitz were associated and work at Databricks. They're also associated. Ben in particular, he's a major investor in some of these other companies like Aptio, like Foursquare. Ion Stoica is also related and a member of 2 other companies that he's founded. One is around a company called Conviva, and he's also associated with the computer science department at the University of Berkeley Computer Science department, I suppose. So you get the idea, right? So I can begin to look for this kind of information, ask more details. Maybe I want to understand who else works at Databricks that I might be interested in at this particular company. I can kind of look at that information. Yep, there's 6 more people associated with that organization that are potentially of interest. Maybe where is the company office located? What was the which financial organization invested? As you can see, is Anderson Horowitz that invested in it, and what was the last round of funding? I can kind of begin to see details of those funding rounds and when those funding rounds took place. So again, I am connecting this data based on those concepts like company and funding and people, concepts that are relevant to an investigator in this scenario, without regard to where the data is stored, how the data is structured, and allow for this sort of notion of a federated access to bring back this information to allow better decision-making, faster decision-making, and deliver these new insights. So it's shifting gears. What does this all translate to, in terms of how we think about this from as data innovators inside our own enterprise, right? You've heard modern approaches being talked about. Data fabric is one of them. Data mesh is another one. Gartner talks about this notion of a dynamic, composable, highly emergent knowledge graph that reflects everything that happens to your data as part of the data fabric. We were at the Gartner conference a month ago now. It feels like a distant past, but Gartner's analyst Adisham Zaidi, his opening remark was knowledge graphs are the secret ingredient to a data fabric. And what that really translates to, practically, is this idea that you're creating this semantic data layer that is powered by this connected knowledge graph of various business domains that sit on top of where the data is stored, whether it's your set of data lakes, data warehouses, operational data stores, but represented in almost in ways that reflects the notion of a data mesh, right? So this domain-centric data product that can also be brought together to facilitate analytics, either for machine learning purposes or to support digital application rollouts, part of digital transformation, internal reporting and auditing, or even external data sharing, right? So the idea that you're kind of working with data in the context of those domains that have business meaning attached to them, and leaving data where it needs to be. So you limit the data sprawl, you limit the issues around governance, and you reflect these as canonical data models. You reflect these with these domain-specific rules that might be relevant for one business unit or one functional area of the business and not so much the other. So you don't have to have this notion of everything has to be one big, huge knowledge graph with everyone has to agree on what a definition of a customer is to them, where frankly it may mean different things to different groups or different business units in terms of how they want to represent that. But they semantically align, right? They mean the same thing. And so having that semantic alignment with those domain rules that are particular, that are specific to your domain or your particular area of the business, can be left separate with your own data access policies that you can define off of those. How does this all kind of become a reality? Well, again, there's this sort of 5-step approach where you take data where it's stored. In terms of the heterogeneity of the data, we're able to enable this creation and integration across these silos that get ingested. So we harvest the metadata to reflect everything about the data that's there, whether it's through the lens of an existing data catalog you've already built. It could be Colibra, it could be Purview in Microsoft, it could be Unity in Databricks, or connecting directly to the source itself. Some of this data then can be either ingested or materialized. Some of this data can be left at the source and virtualized or federated over, and then semantically enriched. So you encode this metadata with real world context. So you attach meaning to the underlying metadata, and then you create these set of inference rules that are again based on business rules for a particular business unit or a functional department, or this can be just applied baseline logical reasoning, A equals B, B equals C, so we know A equals C, or you can apply machine learning, statistical inferencing on that data, eventually with the goal of presenting this information back to your consumers in ways they want to consume it, right? Whether it's in the context of a BI tool, so everything gets represented as a SQL endpoint to them, or whether they want to ingest that into their notebooks so that they can build machine learning models on top of that, or they want to present this information into an existing application, in which case, they can do that through Java APIs or REST APIs or GraphQL. So that construction happens there. Ultimately, the goal is what? Sort of closing this last mile to data democratization, right? So you want to be able to look at all sources of data and not have to worry about creating complex data pipeline every time you want to bring a new source of information in. You want to be able to model information the way you think about things, not how you structure it as strings, if you get the pun. And then have this sort of standard vocabulary be the way you share information, you reuse that in other parts of the organization, and then eventually uncover new insights, using machine learning based models that reference sort of this knowledge graph embeddings, or inferencing based approaches to infer relationships based on domain specific rules to really uncover new patterns in the data and provide new insights, with the goal of what? Improving data analyst productivity. You're reducing your time to market, whether it's for drug discovery or time to market in terms of quickly responding to issues with a particular part in a vehicle, or responding to needs of the business from a financial crime perspective, right? It's all ultimately money saved is money earned, right? As we've learned growing up, and you're creating these new revenue streams along the way. Again, in the context of life sciences, that was obvious. Maybe new products and services you're offering from a financial services perspective as well. And this is not just, this is not benefits or outcomes that we hope companies get. We are actually already seeing these relationships. Sorry, I went back. We're already seeing benefits of companies that have already adopted this approach. This is an independent study that was done, an ROI analysis of companies that have employed and deployed a knowledge graph platform. And those have translated, and these studies are available, translated into productivity for data scientists and data engineers by 75 to 95%, or computing the salary and the cost associated with bringing these individuals on board, translating to roughly about $3.8 million in benefits, faster analytical developments, faster time to market, right? Being able to do this 2 or 3 times faster rather than having to wait for these complex data pipelines before you can actually make sense of the data or use the data. You can leave data at place, so you can accelerate that analytics development timeframe. Infrastructure saving, because you're not copying data, you're not storing data, you're reducing the amount of infrastructure investment you want to make, and you're driving increased profits for the organization because you are uncovering, frankly, new sources of revenue. Perhaps you're saving the company money in terms of being able to quickly respond to issues as they arise, or risks that you're able to quickly respond to as well. Ultimately, that translates itself into like a nice $9.8 million ROI over a 3-year period for a lot of our large enterprise clients. Of course, we also hear quite a bit, what kind of skill set do I need? Do I need to train people in something that is so new in the market that we just won't have the resources? The answer is no. I mean, this knowledge graph technologies, are, believe it or not, an aggressive area of study in a lot of the universities, especially around semantic web. But more importantly than that is that, there are tools out there that are purpose-built for individual personas, whether they're data modelers or data engineers. So if they work with similar tools, they will find working with a platform like ours, much the same way as they do with other tools, right? The idea of data modeling, the idea of exploration, the idea of mapping your particular sources of information, being able to visually define queries and quickly present that back to your users. That's the benefit. You're making your users more productive, independent, self-service, and that drives a better sort of honestly, the way you interact with your business counterparts is by making them independent and making them productive. And then they start to see value immediately. And of course, this is built for scale, right? I mean, anything here, it all sounds good in terms of a small dinky data set, like I showed you with the royal family. But this needs to be built for enterprise scale, so be able to work with large amounts of data. And we have, again, independent studies that demonstrate our ability to scale up to 1 trillion triples and being able to respond in sub-second query times, where 85% of the data is virtualized across a multi-cloud infrastructure. About 15% of the data is materialized, and be able to deliver that fast, effective sub-second query response time. And then demonstrable savings in terms of infrastructure costs for comparable technology, where the reliance on the amount of capacity or CPUs or RAM is drastically limited with an approach that we take that has order of magnitude cost savings for our clients. For those, of course, that are interested and keen and really want to get started, we do have Stardog.com in the cloud available to get started for free. So go to stardog.com or stardog.com, get started. You'll have access to a whole host of knowledge kits that reflect some of those industry use cases I talked about. You also have tutorials. You kind of walk through your own individual time frame and experience the notion of a knowledge graph and a semantic layer, kind of see it in action yourself. Obviously, if you're a little serious and are ready with the project, it's a good way to get started with that, as well as our essentials offering. And if you are a Databricks user, for those that are familiar with Databricks, we are part of their Partner Connect program as well. So within the Databricks workspace, if you go under Partner Connect icon, you'll see a semantic layer category, and you'll see us reflected as one of the options that you can connect to directly from your Databricks workspace as well. So with that, I'll kind of end here. Hopefully this was insightful for you folks. Hopefully I opened some minds. Maybe I created more critics, detractors. Regardless, I always appreciate the opportunity to present a point of view. And that point of view certainly is open for criticism as always, and happy to take any questions. Can I use pre-existing ontologies with Stardog? The answer is absolutely yes. In fact, some of the industries that I talked about, there's a lot of work that's already been done by various organizational subcommittees that are representative of the large enterprise organizations within those industries. So life sciences, pharma, you'll see representatives from Pfizer and Amgen and Merck. If it's manufacturing, you'll see representatives from companies like Bosch, Schneider Electric. So yes, there's absolutely ontologies that kind of help accelerate some of this. We're taking steps to help create and accelerate the creation of those semantic data models. And to that extent, we're leveraging, even looking at ways to leverage the power of large language models in drastically being able to accelerate the creation of those semantic models relevant to your use case, which is an important aspect of developing that knowledge graph, that first knowledge graph for your particular use case. I see there are some other questions. I like to think semantic layer is a type of model on top of conceptual data model. Absolutely. Victor, thank you for your comment. For those, it reminds me of data dictionaries and labels. It's a new concept for me. Appreciate your comment there. It is absolutely data dictionaries, taxonomies are sort of subset representatives of the larger vocabulary. I kind of think of this as a vocabulary that you are bringing to the organization. You talk about data literacy. You're talking about how do you move to that next generation of training large language models for your enterprise? Well, knowledge graphs can really create this business vocabulary for your enterprise data and feed large language models to then drive AI specific use cases as well. So that's another area of opportunity here. Question around, how does this compare with Purview? Purview is specific to metadata and data cataloging. The good news is we actually can connect to Purview and harvest the metadata associated with Purview, but at the same time, we do that across a whole host of other sources of data. And more importantly, we're taking the metadata and enabling users to not only query and ask questions about the data, i.e. the metadata, but also get access to the sources of the data itself. So you can actually, when I was looking at that particular VIN number or in the vehicle and manufacturing context, I was actually getting the specific record that sits in a specific source, which could be Databricks, which could be sitting in Azure Data Lake. So it's taking an approach that combines the metadata with the actual data, so that so when you're querying for information, you're actually getting real information presented back to the user itself. So in that case scenario, Purview becomes another source for which we can enrich semantically, and on top of which we can semantically enrich and present the data back to the user, sort of more in an accelerated fashion, so to speak. All right, I know we're at the time. Navin Sharma, I'm on LinkedIn. If you want to hit me up, more questions, happy to continue the conversation there. Otherwise, continue on with your next sessions and have a good rest of your day. Thank you.